This week, our very own Joff Thayer is going to talk about how to build your own home router. In security news for this week, Mr. Jack Daniel joins us back in studio for the first time in quite a while. We're going to talk about Apple versus the government, which is going to be very interesting. We're also going to talk about Instagram and two-factor authentication, because you need that to take your selfies. All that and more, so stay tuned. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. Black Hills Information Security, the leaders in penetration testing and active defense. Email consulting@blackhillsinfosec.com to request a quote today. ProXPN is the leading VPN service offering free accounts, excellent premium features, and an outstanding commitment to privacy and security online. Use the discount code WEEKLY and save 50% off for life. Onapsis, the leading provider of solutions to protect ERP systems from cyber attacks. Customers can secure their SAP and Oracle business-critical platforms from espionage, sabotage, and financial fraud risks. Visit them on the web at onapsis.com. Pony Express. Check out their line of penetration testing devices, including the Pwn Pad, the Pwn Phone, and the Pwn Pro. For enterprises, there's Pwn Pulse, providing continuous visibility into wired, Wi-Fi, and Bluetooth spectrums across all physical locations, including remote sites and branch offices. For all those hard-to-reach places, there's Pony Express. Visit them on the web at ponyexpress.com.
And now, here's your host, who I'm supposed to say something amusing about. Something about gray hairs and wow, you got gray in the past 6 months since I've been in studio.
You know, wife,
kids,
job,
yeah, yeah.
It's life.
Tell me about it. Tell me about it.
You've had a pretty stressful life, if that's what we're using the cage, Jack.
You want to talk about gray hair?
No, I don't want to talk about that gray hair. I want to talk about how we're welcoming everyone to Security Weekly. This is episode 452. Of course, your host, Paul Asadorian, joined in studio by Mr. Jack Daniel.
That's me, right?
You're here in studio making some fabulous cocktails with Unilever.
With Unilever, yes.
Yeah, it's good. I like it.
It's tricky to get because it's an interesting profile. A lot of things don't play
I fail
nice with
every
it.
time I make a cocktail with Unilever. I fail. That's good though.
It's yeah.
It's finicky.
It's finicky.
It's like a woman. It's got to be done just right to get enjoyment out of. Anyway, on the line via Skype, Mr. Carlos Perez joins us. Welcome, Carlos, to the show.
Hey, Paul. Happy to be here.
Yes, very nice to have you, Carlos. Mr. Michael Santarcangelo's here with us as well. Welcome, Michael.
It's always interesting to be here.
Yes. We had an interesting pre-show kind of thing. Our guests, we'll have to bring them back on next time. So Mr. Joff Thayer, who's also on the lines via Skype, was kind enough to take on this segment.
He's peering over your shoulder there.
Yeah,
that's right.
G'day. I am peering over your shoulder. G'day, Paul and Jack and Carlos and Mike. Good to be here again on this wonderful evening. And yes, I did kindly volunteer. Or was that voluntold?
Voluntold. You were voluntold. Joff, segment. Woohoo!
Oh, we're going straight into it, are we? Okay.
No, well, so a couple of quick announcements I have. InfoSec World 2016 returning to Disney's Contemporary Resort April 4th through the 6th. I'll be there. Mr. Michael Santarcangelo is scheduled to be there.
I'll be there carrying your bags, baby.
That's right, carrying my bags, baby. And if all goes well, someone will do a song and a dance to introduce my talk, which is going to be awesome. Which I have to write, by the way. I have to put some slides together for that. So there'll be tons of stuff there. It's a great conference. It's in sunny Florida. Some familiar faces will be there. Maybe some not so familiar faces that you should go check out, watch their talks. There's also training. Go to or Google search for InfoSec World. I think it's infosecworld.misti.com, org, something. Anyway, you'll find it. I'll get you the URL in the next segment. How's that sound? I want to also mention a company that I don't know. We have mutual friends that I think that work there. I was actually
some smart folks
that work for Duo Security. and they're looking for a product marketing manager. So they're looking for a rock star product marketing manager to join Duo's team. Duo's a cool company. They have cool technology, and I think it'd be a really cool place to work. Our good friend Simple Nomad, works there. At least he did the last time I talked about Black Hat last year. I'd imagine he's still working there because he's a good guy and they're a great company. It seemed like a great fit. So I wanted to give them a shout out on the show. And, for anyone in product marketing, or if you know people in product marketing, they're maybe looking to get a job or looking to make a move, this is a pretty cool company with really cool technology.
Yeah, they have they've done some interesting stuff ahead of the game, I think, in some ways with mobile stuff, and the market's starting to catch up, but hasn't caught up with what they've done yet.
Yes,
good stuff there at good folks at Duo.
Cool. So, Mr. Joff Thayer, we're going to talk about home routers and how to build your own home router. Oh, we lost Joff.
Oh, there we go.
There we go. Joff's back.
Unmuted.
Sorry. So,
okay.
Joff, I just want to set the stage. There's a lot of ways you can go here, right? I mean,
absolutely.
You can buy off the shelf low end stuff, which I've had low end stuff. I have not had good success with. People that buy it don't have good stuff. I mean, you can even get the one that comes with your cable provider. In some cases, it's not bad. Actually, the ones for Verizon actually are designed to keep up with the bandwidth that you get. They're not bad, right? They're going to lack the features that you want, but speed-wise, they're not bad.
The speed's there, but they're designed for ease of use, and they're not configured for security often, as we've discovered through the years.
You can buy low end. I don't recommend anyone buys low end. If you're serious about the internet,
they fall over. I mean, a lot of that low end stuff, you will overheat and you will slow down.
If you're one person and you want to stream Netflix or Amazon or Hulu consistently in high def, or God forbid 4K, the newer devices support 4K. Right. Dude, you're not going to want that low end router.
No,
very
you
bad.
don't want that.
Absolutely not.
And then you can buy high end, right? And mixed success there. I think sometimes when you buy high end, you get good hardware, but you get sometimes crappy software. And you have to know to either put an OpenWord or a DDWord or pfSense on the hardware that you buy. And know how to configure all of that. I know Ubiquiti makes a high-end, really nice hardware, but the software they have on there is people are saying in the reviews, hey, if you run Cisco routers and Cisco gear for a living, then you're going to be right at home with the Ubiquiti device, right?
Right. That's exactly. So you run it's like running a Cisco ASA for your home firewall.
Yes, exactly.
And an Aruba for your home wireless.
Yes.
The only people that do that work for resellers of Cisco and Aruba because that's not user friendly.
And then I think where we're going, Joff, is a build it yourself, right? And I mean, you can use any kind of, if you're going to build it yourself and you know how to tune it, I mean, your hardware choices are pretty open, right? I mean, as long as you got enough processing power to run and do what you want to do, I think you're in good shape. And that's when I want to kind of turn it over to you.
Yeah, absolutely. My approach has always been to use commodity hardware. I've moved to flash-based PCs.
I was just going to say solid-state drives when we're talking about this, right?
Yeah, solid-state drives. Oh, let me... Yeah, we got that.
Wow. What
make
did I
it
put
bigger,
in these
Joff.
drinks?
Make the text really big.
Yeah, so I just want to go through just a couple of examples on how you build this. And this is a Linux-based approach. It's a Ubuntu operating system. It can be any generic Linux with IP tables, frankly. And what I'm showing you here is just a command line window that's SSH'd into my actual gateway that I'm talking to you through. And I'm going to show you a couple of files. So essentially, there's three components to building a home router for yourself with a Linux-based system. Essentially, you're talking about an IP tables configuration. You're talking about some DHCP configuration and perhaps some DNS configuration if you're interested in running your own DNS, okay? And then you're talking about the hardware components, which at minimum is a PC with 2 NICs on it. And you can get away with having that inside interface and then that outside interface. Now, of course, on the inside, you probably want to switch to handle your inside traffic. and the outside is going to face your ISP.
And what are we talking about for CPU and RAM on this system, Joff?
Yeah, so I'm running this on a flash-based PC that is by the Socrus guys. There's many of them out there. There's Netgate, there's Socrus, there's a number of different vendors that do the small footprint fanless kind of PCs. We're only talking about a gig processing power, or about a 1.6 gig Atom, Intel Atom.
So you went this is like an embedded type system, right?
It's an embedded system, exactly, and it's perfectly manageable on that system. And just to give you an idea of the throughput numbers, in my case, I've got fiber in the house, and I'm running 50 megabit down and about 30 upstream, and I can get full streaming capability through this device without any problem at all.
I know a lot of people that want to have like more sessions. So if you've got multiple people in your house that want to stream, or you're going to run port scanning or other kind of scanning through it, or do stuff that's going to create a lot of sessions, you're going to want a lot more RAM and CPU. And so people just buy like small PCs rather than the embedded system. The jobs you can buy small PCs.
For sure.
If you want
just to give you a sense,
I was just going to.
This embedded system's running a gig of RAM and about a 1.6 gig processor, and it's perfectly capable of handling. I got Netflix in the house. I've got the kids running rampant on wireless. Now, this system itself is not using wireless; they're separate APs.
Right.
But it's more than capable of handling the load of a teenage household, which is a pretty decent network load.
Our friend Steve McGrath uses is a big fan of the Zotac hardware. If you use
Zotac for the show,
if you need to make the next step up out of that into an Intel
Zotac
type
is great. We have 3 Zotac machines here in the studio.
They're solid.
Great. Different levels. There's like really low end Zotac
there's
stuff,
really low end.
Which not that it's. I shouldn't say that it's cheap, right? It's just. It's inexpensive, but the value that you get even for the inexpensive one is really good. I mean, we have one that's like a Celeron processor. It's really small. We use it to like play a video on a TV screen or monitor a chat room or something like that, right?
Yeah, but
it's good box for
it's
that.
like everything else. Think about what you're going to do and size it right. Because I do some lab stuff with dual core Atom boxes, which are underpowered. That's again moving up from the ARM stack or the Atom. Right. But think about it. And anyway, let's.
So sorry, Joff, go ahead. Now let's talk about the config.
No problem. So I'm just going to run through the config. I've got a window up here that's showing the network interfaces config for starters, because that's a nice place to start. So the particular box I'm running this on it's a Socrus 6501, which is a pretty capable box. It's got an Intel Atom on it. It's got a gig of RAM in it. And it's got a flash-based drive in it. It's got an SSD in it right now. You can actually have a spinning drive as well with a SATA interface. So you got a lot of options there. In particular, I'm running a 4-NIC configuration here, where I've got ETH0 facing the outside, and then my ETH1, ETH2, and ETH3 interfaces with 3 different internal network segments in the house. And this is a picture with some edits of my actual configuration. So let me run through some of the facets here so you can see what's going on. Of course, I'm bringing up a loopback because no Linux box worth its salt is going to operate without a loopback interface. And the very first thing I do is bring up my IP tables config after the loopback comes up. And then I have some security features added in here. I'm actually got some high metric routes that route RFC 1918 essentially to the sinkhole. They're routing them to 127.0.0.1. As well as routing the multicast IPv4 space to 127.0.0.1, should there be any interface problem. And this is like a classic network engineering kind of technique. If one of the interfaces goes down, it's going to sinkhole the traffic. Okay. Moving down, I have edited some of these values for posterity because I'd prefer not to advertise my public IP space to our listeners. But here's our public network address, which is a static configuration in this case. I happen to have a /28 network. I just replaced a few values here, so I'm using 255.255. Don't do this at home because you like using the broadcast IPv4 space, and this is probably not a good idea. Pretty much, I'm just configuring an interface with a static gateway, which is pointing to my ISP's gateway device that they supply me. Okay, and then with a DNS name server of localhost. So in this case, I am running DNS on the actual gateway device. And then in terms of the internal networks, I've got 3 different segments here that are sequentially configured: 10.111, 10.211, 10.311, which are just 3 Class C networks on the inside of the house, right? Any questions about that from
Yes.
our illustrious panel?
I have a question, Joff. So, what do each of your 3 internal networks do? What's the purpose? Is there a use case for each one of those? I'm assuming.
Yeah, pretty much there is. ETH1 here is my network, and nobody else shall touch it. ETH2 here is kind of the kids' wireless space, and then ETH3 is like voice over IP and other miscellaneous things like Netflix and such.
I gotcha. So you separate some of your like IoT device type stuff on one network, and then
Exactly,
the Wi-Fi is
exactly.
on another network, and then you have your own like Joff network for Joff stuff.
Yeah, in a perfect world, I'd have that segmentation nicely configured. In the real world, a lot of stuff tends to end up in the 10.111 network, but that's the intent. It's sort of partially there in my house because, like many things, you're only your time devoted to your own network is about I don't know 2 milliseconds at the end of a Friday.
Yeah, I know.
You know?
Ideally, I would have a separate one Joff as like a guest Wi-Fi.
Exactly.
And it's
exactly.
a protected Wi-Fi. It's a password that I can give out. So when all of your children's friends visit and they're like, "Oh, I want to connect my phone or my tablet," you give them that Wi-Fi network.
Now, in my particular case, I'm one of these very weird individuals. I don't know. Maybe we're not so weird, but I run an ESX server at home, and my Wi-Fi is actually a Cisco virtual Wi-Fi software instance with Cisco APs. But
Nice.
most people don't have that kind of capability. It doesn't mean you can't have APs just sitting on the network and receiving traffic and having at it. So I do recommend separate APs for anybody's network. I think running a stack where you've got a single AP on your home router, if your house is big enough, that's just not going to cut it. In my case, I've got 3 access points across the house. It really depends on your scale. I'm talking 2,600 square feet here, and 1 AP is just not enough to cover the space.
Yeah,
So,
I use the Ubiquity routers that we've talked about on the show before.
Yeah.
Which I have 3 of those, on the 3 channels for 802.11. B, well, not B, really it's G primarily now. And then we also have N, separate access point for N.
Exactly. So, so that's it's nice to have more capable APs, as Paul is pointing out, especially those that are capable of, in the wireless case, are capable of doing the handoff for roaming. That's particularly good because if you've just got a standalone AP, you've got a situation where they're not really aware of each other and they can't do a nice handoff when clients are roaming around the house, which they do.
Yeah. I use one giant, extremely high-powered AP, but then I'm done having children.
Well, that's a perfectly acceptable approach
good.
as well.
Yeah.
Well, in a location that's a single story, not going up and down, and like I said, I'm done having children, so the microwaves are okay. They can go right through the old.
Now, in my case, I'm right in the throes of teenage life.
Well,
here
on
at
the
home.
upside there, you want to sterilize them too. So
Yes,
Well,
you do.
well, the funny thing about this network setup is my daughter invites her friends over because we have the best network in the neighborhood. So they want to jump on it and use it.
I'd be
So,
ashamed if it were any other way, Joff.
Yeah, exactly.
Yeah.
So let's
Also,
go
one has
through.
to be
Wait,
careful
go
between-
ahead,
Go ahead.
Carlos.
Carlos.
Also, one has to be careful. There's a difference between what is an access point and a router. So if you're putting a new router, it will have DHCP by default. It will,
Yes.
as it says, route from one network to the other versus an AP, which is just like a bridge.
Right. That's a very good point, Carlos. In my case, all the APs are purely bridges. They're just there, designed to receive traffic and nothing else. The DHCP services are going to come from the actual firewall gateway, which is running on my flash-based PC.
Yeah,
and I'm going to go over that. In just
and
a
you
minute.
can get the off-the-shelf hardware and put DDware on it and put it in AP-only mode and get more configuration ability to just make it a bridge rather than a router. Because a lot of the off-the-shelf stuff, like when we wrote the book about the WT54Gs, like they come out of the box designed to be your firewall and your access point all in one. You should totally, people listening to the show know, right? Separate that
Right.
stuff.
Don't
have
do
a
that.
router that does the routing, have your access points that do the Wi-Fi, have a DNS servers that do DNS and DHCP that does DNS. And that actually, when I was doing it back in the day, like we didn't have Netflix and all the streaming stuff. I mean, I was just doing it for fun, really, and just to build that architecture at my house. Now I think you can really benefit from that. Also, on the flip side, a lot of us work from home.
Yeah.
And we're doing stuff to support our jobs and need not just the availability, but that ability to troubleshoot and the ability to do like work stuff from your house. And having that separation, I think, really, really helps.
Yeah, absolutely. So I'll just run through the Nat config here really quick, just so you guys can see that. So this is your standard IP table stuff. We have a pre-routing table, an input-output, and a post-routing table in Nat. Anything you look up online about NAT and IP tables is pretty much going to give you this kind of line here to NAT everything out to your external interface. And that's a pretty good and solid configuration, right? I've got a couple of things in the NAT configuration that are useful here. On this particular gateway, I happen to be running a squid proxy. And so I actually do some redirection of TCP port 80 traffic, which is typically web, and I send it to the squid proxy actually on the router device.
Are you doing a caching proxy, Joff?
Yeah, it's a caching proxy, exactly.
Nice.
So that helps me save a little bit of bandwidth. It's an option. You don't have to do it, but that's what this line here.
Yeah, I found when I got to like 70 meg down and 30 meg up, I found I didn't have to do a proxy, but I mean, that can make pages load faster. So
yeah, I've got a static DHCP lease for my particular host, and I exempt myself from the proxy, but everybody else has to suffer through the proxy. So,
gotcha.
So that's the way it works around here. And then here, I'm using a source network on the NAT statement because my internal network's in the 10 space. And then I'm natting everything out to ETH0, which is the static IP. So that's pretty straightforward. The filter rules, however, are a little bit different. Now, as a good security professional, I've gone ahead and put a bunch of security features in on the filter rules here. And so let me just walk through this. First of all, on ETH0, there is no reason for you to actually accept certain network traffic on your external public IP. Things coming to zeros, things coming to 127.0.0/8, things coming to everything RFC 1918, and things coming to multicast if you choose not to route multicast, which most people don't, have no reason to be accepted. So in all those cases, I'm actually logging and dropping that traffic on my outside interface. Okay.
It's funny, when I was working with the network team when I worked for a university, we configured all the same rules, and I taught them why and went through all that in a gigantic network. So it's funny to see that those rules apply no matter how you're
no matter what the size of the
right,
network.
Exactly.
Yeah, I mean it's just sort of good hygiene. A couple of other things I'm doing, and that I'm a little bit extreme on this point, but some people would agree with me. I'm dropping IP fragments just flat out at any interface, and I'm also dropping any packet that has a TTL less than 4. There's no reason for it to route inbound, outbound. So that that's my decision from a security perspective with my network. So it's extra special sauce in the configuration. And then I go through and drop a few obvious TCP and UDP artifacts here. TCP port 0, UDP port 0, TCP with the Christmas attack or all flags set, and TCP with none flags set. I actually highlighted those backwards, but so some basic security hygiene there, but is what we're talking about. Okay.
Are you logging those rules at all, Joff?
In the particular case of the hygiene stuff, I am logging most of it. Actually, I meant to have log drops here.
Do you see like a Christmas style attack still?
I generally don't. I still think it's good hygiene to have it.
No, I agree. I'm just wondering if you still see those attacks. It'd be kind of interesting to.
Yeah, I'd have to go back and filter through the logs, and again, it's that 2 milliseconds at the end of a Friday. I generally don't have much time to filter through it. I anticipate that my hygiene is good enough that it's going to cut down most of the crap, which it does, frankly. So then, just some rules, and I want to be clear on this. The first thing about IP tables here is the rules for input and output traffic refer to the Socrates box itself. They're referring to the router itself. They got nothing to do with the traffic that is forwarding across the interfaces. So with IP tables, when you've got an input or an output rule, it's a traffic that's initiating and terminating actually at the box. Okay. So here I'm doing DNS, so I'm allowing DNS replies to come in, right? TCP and UDP. I'm doing DNS on the inside of the network, so I'm allowing TCP and UDP 53 to be queried on the inside of the network. I'm also doing DHCP on the inside of the network, so I'm allowing UDP67 to come in on DHCP, right? So this is a standard, fairly secure configuration. I'm also doing some NTP stuff for time-based synchronization, so UDP 123, and then the SQUID stuff here, you can see 3128, and a little bit of ICMP policy, okay? So that's my input rules. On the output side, and again, this is initiating from the gateway itself, loop back everything except, because that's, well, frankly, the way you just need to do things. There's a lot of socket-based stuff that uses loopback, and you don't want to drop that. I'm allowing outbound 22, so I can SSH from the box to places. Outbound 25, so I can actually talk to some things. SMTP, that's more diagnostic for me. DNS, and then some outbound, in particular on the public side, who is HTTP for web, NTP, HTTPS, some IPsec stuff, and then some odd stuff that I configure as needed, sort of ad hoc at the time. All of this is initiating from the box itself. So we're just going to move on. The HTTP, just to make a quick comment, the HTTP, HTTPS stuff is largely due to Ubuntu updates. I need to go fetch the updates for the box, right?
Is that the Linux distro you're using on the firewall?
Yeah, the firewall itself is an Ubuntu distro, so that's what I'm needing to do for those purposes, right? I'm going to move down. Oh, first thing to say is iptables has a stateful mechanism in it, and so once you've defined the actual rules, to get a state match and get the reverse rule placed in the table, you need to actually invoke the state table. And that's what these last two lines effectively are. Input M state, related establish, accept. So we get the reverse state established when the connection is seen. Okay. Same with output. All right. Here we're doing log drops on the input and output as the last chain in the rule set. And that way we get our logs for anything that doesn't match the existing set. All right. Down to the forwarding. So the forwarding, and you can choose your poison on this if you want, but pretty much on forwarding, what I'm doing is saying, if you're on my internal network and you want to forward TCP and UDP anything, go ahead. If you want to forward ICMP anything, go ahead. Now, that's a fairly loose policy, but that's only because I don't want to get into the game of fighting with my kids, frankly.
Yeah. Daddy, I need this port open, right?
Yeah, about what port needs to be open. You don't have to play the game this way. You can certainly restrict further down to port sets and do all the things that iptables is able to do. But this is the guts of actually what you're allowing outbound on the network to the internet. This is where it's at, okay?
And of course, any rules there your kids could bypass by using their Pro XPN account with their 50% off for life.
Yeah, they absolutely could. Now, note that I am filtering by protocol specifically, though, so I'm not letting any willy-nilly IP protocol go out. I mean, IPv6 won't go out on this network, for example. You're not going to do any ISOTAP tunneling. But I am letting some IPsec stuff go and some authentication header stuff go here as well, because I have some VPN needs. So that's the forwarding rules. Everything else in this configuration file is about logging. Pretty much I have a last chain here, which is called log drops. That's where all of the rules forward their stuff if they don't match as a last rule in each case for the input, output, and forward chains. And this will simply log, well, actually adds a log prefix of iptables, at which point I use syslog rsyslog in the Ubuntu case to match this iptables for prefix and write it to a dedicated log.
I gotcha.
Okay.
And you write that on the box itself, or do you send it somewhere else?
It's actually written on the box itself in this case, small scale. I hate it when VI does this to me.
Someone else is calling too, huh?
So, for example, varlog iptables.log, and I get a whole bunch of stuff there, right? And that's my syslog logging stuff, okay? I'm not going to show that for long because I really don't want to show my IP addresses. The other thing is DHCP, okay? 2, 3, 4. I want to keep this short, Paul, and I'm making it longer than it should be. DHCP kind of looks like this. Pretty much for the internal segments, you want to do this for each subnet. Very, very simple, right? You've got a DHCP configuration that gives a lease time, gives a syslog destination, gives a domain name server. Now, if you decided that you didn't want to run your own DNS, you can certainly do something like this with your domain name server and configure your DHCP with like Google's DNS. no problem. Go ahead. It doesn't matter. It's up to you whether you want to run DNS or not. But the idea here is I'm just giving out addresses on the inside of the network with a specific range and the router address of that interface on the inside of the Cercus box. Okay? Makes sense?
Cool.
Yep.
Can you share that with the world?
Some of these configs I would love to share with the world, and maybe we can do a little post.
I'd have to sanitize it, but that would be great to. I mean, especially if you get this, we air this segment in post production, Joff.
Yeah.
Imagine we're going to get requests for your configuration. So if you're willing to spend a little time and sanitize it and post it, we'd love to post that for you.
Yep, absolutely. Some of the things that also can be helpful, and I might post this as an extra thing. I'm running my own DNS, and I'm running Bind9, which is Internet Software Consortium Bind9. And I have a neat little script here, which actually reaches out and gets the malware domain list from DShield.
Yep.
And after this script gets the malware domain list, and I can publish this script. I got no problem publishing it. It actually converts it into a DNS zone file. And if you look at this, everything in the sorry, it's a configuration file, not a zone file, but everything points to this thing called db.blackhole. Okay, so anything that's published in the DShield list that our friend Johannes publishes actually gets black holed in my DNS. And the db.blackhole in this case is very simple. It simply resolves everything to 127.0.0.1.
Yep,
So
that's the way to do it. Yep, because you have to get a response, otherwise it just spins for a long time. Well, what seems like an eternity, but is probably only 30 seconds is an eternity, right?
Yeah, so that's a nice little extra feature that is sort of a nice, really value-added security feature that actually has got a lot of utility, I think. I want to point out one more thing, and that is when you're doing a router, you actually have to set the net.ipv4.ip_forward flag in your kernel to 1. Typically, that is set in the etc6 syscontrol.conf. Let's see, somewhere here. Well, I'd have to grep it. But what's important is this is set to 1 because the Cercus box has to be able to forward packets from the inside interfaces out to the external public interface. And without this flag set to 1, the forwarding will not occur. It won't be able to route packets. Okay?
Cool.
So that's it. That's the super fast session on how to build your little router. I will publish some stuff on the Security Weekly resources about it, put a little packet together, and hopefully people can whoa, I got a little video effect
Inception going on there.
There you go. Hopefully people can download that and make use of it, and hope it's very much fun for folks, and they can have fun doing their own. It works great. I get to stream data all day long at 50 meg plus. I've never had a problem with it, so
awesome.
It's really cool.
Well, thanks, Joff. And stay tuned. We're going to come right back. We're going to talk about the security news for this week. We're going to talk about Apple versus the government. It's going to be the hot topic of conversation, I think, in this next segment, as well as a lot more. So stay tuned. Don't go anywhere.